All right, Algebra 2, Section 3.2, solving systems using some algebra instead of just graphing. I do want to remind you that from the Section 3.1 notes, we talked about how systems can be independent, meaning they cross one time, dependent, meaning they cross an infinite number of times because they are the exact same line. They're using the word coinciding. Inconsistent, they are parallel lines, so they never cross. And we talked about how the slopes can be different or the same, and y-intercepts can be different or the same. Now, in the independent, they can, if they cross at the y-axis, then the y-intercept could be different or it could be the exact same. But that would only happen if they cross right on the y-axis. I want you to make sure that you're going through your notes and making sure that you have classified these based on slopes and y-intercepts. Go through these, find the slopes of each of these lines and the y-intercepts, and then determine from that chart which of the three categories you're talking about. These three equations that we didn't get to in our notes today, I want you to make sure that you've gone through and you've looked at those slopes and you know the y-intercepts and where it fits and what the classification would be. Okay. There is a more exact way of solving the systems of equations other than graphing. There are actually three ways total, but we're going to talk about the first way of those three. It's called substitution. You want to notice one thing here, that one of the variables is solved for, so you want to make sure that you are having one equation that has either y or x by itself. In this case, we have y by itself. You're going to notice that I'm going to take this expression, 2x minus 7, expression, and I'm going to insert it in place of y in the previous equation. So you're going to take y out and you're going to put 2x minus 7 in its place. So let's see here. If I do that, I'm going to rewrite the first equation, 4x plus 3, and instead of putting y, I replace that with 2x minus 7. And that's equal to 4. So I rewrote the first equation and did the substitution. We can distribute 6x minus 21. And then we can do the normal things we do for adding like terms and adding things to both sides of an equation so that we can end up with our x value of 2.5. Now, since we know that the x value is 2.5, we can find the y value that goes with it. So y is equal to 2 times 2.5 minus 7. What am I doing? I'm going back to the equation at the beginning that was solved for y. Remember this one? Y equals 2x minus 7. Now that I know x, I can use that equation. 2 times 2.5 is 5. And I can find out that the y value is negative 2. So the solution is 2.5 comma negative 2. Now what kind of situation are we dealing with? Well, let's go back and look at and remind ourselves how to classify them. We classify them by knowing their slope and their y-intercept. Well, this one's pretty easy, 2 and negative 7. Well, the slope here, well, as we said in class, you can either solve for y or we can use our opposite of a over b trick. We talked about that before, that the slope was the opposite of a over b. Some of you will remember that, and some of you that it doesn't make sense. That's okay. You can solve it for y and you'll get the same result. So if you go over here and solve for y, that would be 3y equals negative 4x plus 4, and divide by 3. And you can see that your slope is negative 4/3. And your y-intercept is 4/3. Now, as soon as we see that the slopes are different, we can refer back in our notes to that chart. Different slopes means independent lines, which would cross one time, which makes sense because we did find a solution. So this is independent based on the different slopes. Makes a lot of sense. Okay, let's see a story problem that you might not like, but should probably get used to. Health club memberships. In this particular case, we have a monthly fee. We're being charged every month a certain amount. And there was also an initiation fee or sign-up fee. Sometimes you might see it as a sign-up fee or a startup fee, something to that effect. So we have been told that for 2 months it costs $100, and for 6 months it costs $200. So I want you to look at these two equations that I've set up. It's 2 monthly fees plus 1 initiation cost. 6 monthly fees plus 1 initiation cost. Alright? That's what we're looking at here. Now remember that one of the equations has to be solved for a single variable. So what I'm going to do is I'm going to take this first equation and I'm going to solve it for y by swinging this to the other side by subtraction. Okay? So subtract it over to the other side and get rid of it on that side. So we have the expression 100 minus 2x at equal to y. So that's what we're going to do. We're going to substitute that in here. So we can rewrite the second equation as 6 plus 100 minus 2x equals 200. Now we can start solving. 6x minus 2x. They're on the same side of the equation, so that can become 4x. We want the 100 to go to the other side, so we will subtract the 100 from both sides of the equation, giving me 100 on this side. Dividing by 4 gives me the monthly cost, right? X represented the monthly cost, so it's $25 per month. If we go back to our equation, y equals 100 minus 2 times x, and we put our value of x in, we can find out what our initial cost was. The initial cost is $50. So the initial setup fee is $50 and then $25 a month after that. The second type of or method that will most accurately find the point of intersection is called elimination. Now, when we eliminate, we are adding two equations together. And the answer to subtraction is yes. You can subtract equations. But I'm going to recommend to you that you stick to addition, because more times than not, you guys make mistakes when you start subtracting. You get partway through it and you forget what you're doing and you make a mistake. So we're going to really emphasize addition in our elimination process. So when I look at these two equations, which are in standard form, and the best type of situation for elimination is when your equations are in standard form. What I want to do is I want to see, is there a way that I can add these two equations together right now and get rid of one of the variables? And the answer to that right now is yes. I see that I have negative 2y and positive 2y. When I add those together, they are going to eliminate each other. So we're adding these equations together, which would give us 5x. Obviously, those disappear, and 10 on the other side, giving me a simple equation to solve so I can find out that x is 2. Once I've figured out one of the variables, then I can use it and go back up to one of the equations to solve for y. Pick your favorite equation. It doesn't matter which equation you choose. I'm going to pick this equation because I think that one's, it's just got smaller numbers. Plus I don't have to mess with negatives. It's just, that's what I think is the best one. So x is 2. I do not know the value of y yet. But it really wouldn't matter which equation you chose. So if you chose the other one, you wouldn't be wrong. I'm going to subtract 2 from both sides, giving me 2y equals 1. And we'll divide by 2 on both sides, so y equals 1/2. So the coordinate where my two lines cross is 2, 1/2. All right. Let's do a little bit more complicated example. So here we have a line, and I ask myself the question, can I add them together right now and get rid of one of the variables? And the answer is no, I can't. So I'm going to have to pick a number to multiply one of the equations by, or maybe even both, but in this case only one equation is going to have to get multiplied in order to find something that will help me. I noticed that this negative 2y and this positive 4y would be a good place to start. So I'm going to turn this into a negative 4y. And the way that I do that is to multiply this entire equation by the number 2. You can't just do it to part, you have to do it to the whole thing. And just for fun, I'm going to copy my answer down here below the other equation. 14x, right? 2 times 7x is 14x. And minus 4y. And 2 times 19 gives me 38. So these are the two equations I'm dealing with now. And can I add these together and get rid of one of the variables? And the answer now is yes, I can. So when I add them together, I get 11x equals 33. So when you divide out your 11, you find out that x is 3. Pretty simple. I get to pick one of the equations to plug my x value back into. It really doesn't matter what you pick. You've got really 3 choices here of different equations. You can use any one that you want, because if it's truly a solution, it's going to be on any one of those. So I'll pick the first one. 7 times 3 minus 2y equals 19. So that's 21, so we'll take away 21 from both sides. And we'll divide out the negative 2, giving me y equals 1. And so we found out that 3, 1 was the solution to our system. 3 for x, 1 for y. Okay, now we're going to step it up and make it a little bit more difficult. This is probably about the most difficult it gets. I do have 2 special cases I want to show you. But in this particular situation, I can't just multiply one of the equations by a single number and get rid of one of the variables. So I actually have to multiply one equation by one number and the other equation by a different number. And you kind of get to choose what you want to multiply by. Like, do you want to get rid of the x's or do you want to get rid of the y's? I'm going to get rid of the x's this time, but it really doesn't matter. So I'm going to choose to multiply my top equation by 5. I'm going to choose my bottom equation by negative 3. Now, the reason I do 5, I've got one positive multiplier and one negative, is because I'm trying to get one of these to 15x and the other one to negative 15x. Okay, and that's what I need to do. So, distributing across this, I end up with 15x plus 35y equals 75. And multiplying that one, I end up with negative 15x minus 6y and a positive 12. Now when you add these together, right, because that's what we're doing, we're adding them together, we've gotten rid of the x's, they're gone, giving me 29y equals 87. Divide out the 29. And we find out that y is 3. Take your pick on which equation you want to use to find x. I'll just use this one. 5x plus 2 times 3, because we know that's y is 3, equals negative 4. So this is 6, and so I'll subtract 6 from both sides, giving me 5x equals negative 10. And so we find out, through a little division, that x is equal to negative 2. So we found our coordinate, negative 2, comma 3. So these next 2 examples are not difficult, but they do present a problem if you've never seen what's going to happen. So I noticed right away that if I add these two equations together, I can get rid of the x's. So that's what I'm going to do. I'm going to eliminate them. And when I add them, I get, whoop, those disappear. Whoop, those disappear. Well, that makes it 0 on that side. Whoop, those disappear. Uh-oh. I've got a really weird situation which has just happened. I don't have any x's or y's left. So my question to you is 0 equal to 0 always, sometimes, or never? Is 0 equal to 0 always, sometimes, or never? Of course the answer is always. Now, with that being said, that means that no matter what x value I pick, I will always come up with a solution as long as it sits on the line. In other words, these two lines are identical. This is a dependent situation. There are an infinite number of infinite number of points where these two lines cross because they are the same line. So if we got an infinite number of choices, how do I put an answer down? Well, basically we're talking about all the points on, write down one of the equations. Doesn't matter which one you pick because they're the same one. All points that sit on that line are solutions. So that's what I have to say. I have to tell you every single point as long as it's a solution to that equation. So that's kind of a different situation. Well, what about this next one? I notice that I can get rid of the x's right away by adding. So I add these two equations together, and these cancel out, and these cancel out, so that leaves me with 0 on that side. But over here, these don't cancel out. I end up with 12. So, is 0 equal to 12 always, sometimes, or never? Well, of course the answer is never. That's never going to be true. So, what does it mean? If they're never true, that means that there's never a solution. That means we're dealing with two parallel lines. That's an inconsistent system. Therefore, there is no solution, right? There is no place where the two lines cross. So, substitution, elimination. Those are the two things you need to be working on in class tomorrow. And don't forget, your quarterly exam's coming up next week. So we want to make sure we're reviewing all this stuff. Go back to Chapter 1. Go back to Chapter 2. Look at the chapters, the sections that we've talked about. We did not do Section 2.3 on direct variation, so I wouldn't worry about that one, or 1.6 on the probability. Those are not included because we will deal with those next semester. See you in class.